Section 2.4 is about linear inequalities in two variables. So linear inequalities are like linear equations, but instead of an equal sign, they have one of our inequality symbols, which are less than or greater than, less than or equal to, greater than or equal to. And the solutions of linear inequalities in two variables are ordered pairs, just like the solutions of a line, but it's all ordered pairs that satisfy the inequality. So that means we're going to end up shading one half of our coordinate plane, also called a half plane, because every single point over here would satisfy this equality, not just the points on the line. So we know that the graph of a linear equation, a line, is all points that satisfy the equation, but for an inequality, it's the set of all points who satisfy the inequality, and that's going to be a half plane. So that's going to be either one of the sides of our plane, might it be greater than or equal to. So here are the four different types of linear inequalities, right? We've got our four different symbols. So in order to determine whether an ordered pair is a solution, we're going to use substitution. So let's look at 5x plus 4y is less than or equal to 20. So let's check A. Is A a solution by substitution? So I've got 5 times 0 plus 4 times 0 is less than or equal to 20. That means 0 is less than or equal to 20. This is true. So A is an ordered pair in our solution. Let's take a look at B. I've got 5 times my x value, which is 6, plus 4 times my y value, which is 2, is less than or equal to 20. That gives me 30 plus 8 is less than or equal to 20. Is 38 less than or equal to 20? No, this is false. So this is not part of our solution. So how do I graph a linear inequality in two variables? So first, you're going to graph the corresponding linear equation. So if I had y is greater than x plus 4, I'm going to graph y equals x plus 4. When I graph that line, it's going to be used a solid line if it's less than or equal to or greater than or equal to. Remember when we were graphing on a singular number line, that means our endpoints are included. Well, this means the points on our line are included. We're going to draw our line with a dashed line if I have less than or equal to or greater than or equal to. Next, you're going to choose a test point in one half the plane that's not on the line. My recommendation of a test point, 0, 0. Super easy. Then you're going to see if 0, 0 satisfies your inequality. So let's check that out. So I've got 0 is greater than 0 plus 4. 0 is greater than 4. That's false, right? So if I get a true statement, you shade the half plane containing the test point. If you get a false statement, you shade the half plane not containing the test point. In this case, we would shade the side not containing 0, 0. Let's graph a couple of these. So I have 3x plus 2y is greater than or equal to 6. I'm going to go ahead and solve, get this in slope-intercept form so I can graph it. So I have 2y is greater than negative 3x plus 6. Y is greater than or equal to negative 3 halves x plus 3. So here's my y-intercept. I find my next point using slope. My slope is negative 3. It's going downhill, so I'm going to go down 3 over 2. It's greater than or equal to, so I'm going to graph this using a solid line. And then I pick a test point. You always want to pick a test point. I'll pick 0, 0. So here I have 3 times 0 plus 2 times 0 is greater than or equal to 6. 0 is greater than or equal to 6. That's false. So I'm not going to shade the side where my test point is. I'm going to shade the other side, which would be over here. Which makes sense, right? Because it's y is greater than. But I always want you to pick a test point if you can, just to double check your work. Let's graph 3x minus 4y is greater than 0. I subtract 3x from both sides. Negative 4y is greater than negative 3x. Divide both sides by negative 4. That means y is less than. Remember, when I divide by a negative, I flip the sign. 3/4 x. That means my y-intercept is 0. So I go up 3/4. Here's my line. It's going to be dashed because it's greater than, not greater than or equal to. So notice my line is dashed. Now I want to pick, I want to pick a point, but I can't pick 0, 0, so why don't I pick when x is negative 1, y is 1. So I have 3 times negative 1 minus 4 times 1 is greater than 0. That means negative 3 minus 4 is greater than 0. Is negative 7 greater than 0? That's false. So we're going to shade the other side. We're going to shade the side not containing the test point. So our solution is everything that is shaded, but not the points on the line, but like everything like right up